First of all, if you have any query from the last classes, you can ask. Otherwise, I will start with the
Excuse me, ma'am.
yes.
Ma'am, I could not use my mic before. I'm Srija Mukherjee and I'm present. I hope I'm audible.
Yes, you are audible, but I don't know whether I can give your attendance right now because I have logged out. Just a
But
minute.
ma'am, I wrote in the chat box.
No, I cannot see the chat box. You have to give your answer verbally. Huh?
I'm
Srija.
sorry,
When I'm
ma'am.
giving the
Forgive me.
attendance, I cannot see.
No, ma'am, I had some internet
Okay,
issues.
done,
I could
done.
not use my mic.
Okay, done. So if you have any query from the last classes, you can ask. Otherwise, I will start with the choice under uncertainty. And this is another wing of the consumer behavior. And that will be the last one. So if you have any query,
Yes,
Ma'am,
ma'am.
yes.
Ma'am, I have a doubt regarding that. There is a sentence in the Mardla Miller reference that marginal utility of P naught divided by. Ma'am, I can present or I can tell the exact thing as my laptop going to be hanged. So I use my phone and the PDF is on my laptop. So there is a thing of marginal utility in the second page which you uploaded, ma'am. Ma'am, can you explain it?
ma'am, P naught by P1 equals to 1 plus R. Ma'am, I
This
think
thing
she's.
also, no, there is another thing that marginal utility of P naught by marginal utility of P1 equals to, there is a something relationship.
Marginal
Um,
utility of P naught. P naught is the price.
no,
No, ma'am,
ma'am.
marginal utility of C naught by marginal utility of
Hmm.
C1 equals to 1 plus R. I think she is saying
Okay, so
that part.
you are asking about that, na? So give me
Ma'am,
some time. Yes.
ma'am, I am asking about that, ma'am. P naught by P1 equals to 1 plus R. That part is there, ma'am, but I can't understand it.
Okay, okay,
How?
okay. So for that, I also need the Mudla and Miller because right now I don't have it. So it's better that I will start choice under uncertainty, and after finishing it, I will come. I will bring my book, and then we will discuss it. Right? I think it
Okay,
will
ma'am.
be better, huh?
Okay, ma'am.
As there is a problem from the book, a particular line from the book, so we all need the book. Um, okay. So let me start choice under uncertainty.
Excuse me, ma'am.
Yes.
Ma'am, I'm Shivani Shahu. Could you please mark me present?
No, because now I am logged out. Shruti is by chance present, but Shivani is not possible. Once I
Okay,
Shruti,
log,
ma'am, it's
Shruti
okay.
na Srija.
sorry, Srija Mukherjee. That I did. Once the teacher log out, it is not possible to go back and give attendance for the same class.
Okay, ma'am, it's completely
Yeah,
fine.
so be present in time and try to be audible. Now, this is choice under uncertainty. Okay, what is the speciality of this thing? Okay, the reference of this thing is Pindak and Rubenfeld. As I said, from here I will start Pindak and Rubenfeld. Huh? So here the reference is Pindak and Rubenfeld. Now, what is the speciality of this chapter? The speciality is, look, there is uncertainty. Here also we will discuss about the choice of the consumer, the indifference curve. Everything is very similar, that sort of thing. But the problem is here we will consider the uncertainty which we are facing in real life, right? In each and every hour we are facing uncertainty because we don't know what will come in the next 1 hour, or rather what will come next 1 minute. We don't know. So actually the consumers are living with uncertainty. They don't know what will be after 1 year, whether that pandemic will be over or not, whether they can go outside the home without mask or not, whether college will open in next 1 year or not. So many uncertainties are there in our life. So consumers are choosing based on the uncertainty they are facing, right? So we are choosing the thing now. For example, now the pandemic is there, we should not go outside your home as much as possible, so we are choosing our consumption, our behavior based on this uncertainty. So the same thing happening for each and every stage. For example, you the students, you are very much uncertain about your job market. what you will get after finishing your degree, that you don't know. We also don't know. So this is the uncertainty. But given this uncertainty, you have to choose your decision. You have to think about your decision. You are taking your decision. So so when we are discussing consumer behavior, we should consider those uncertainty. But in our same one, when we discussed about the consumer behavior, we never consider about this uncertainty, but it is there in real life. So this chapter is dealing with this uncertainty. And this uncertainty you will study in details in your PG course. And there they will discuss, the teachers will discuss it in terms of the lottery. Because lottery is a very common thing. And we all know what is lottery. So uncertainty is also there. And when we will discuss uncertainty, we need the concept of probability. Okay, because probability chapter is depending on this uncertainty. As there is uncertainty in the real life, probability chapter is also there in our syllabus, right? If everything is very much certain, no need of discussion of probability. And I hope all of you know what is probability, right? So can you explain what do you mean by probability? Just the idea.
An event which is likely means likely to happen or may not happen.
Okay. Okay. So the event which have some uncertainty. Okay, the events which have some uncertainty, these are called these have some probability. The probability of occurrence, probability of non-occurrence. So you know that. I expect, I just assume that you know all this. Okay, how many of you know about the expected utility? What is expected utility? You did your probability chapter in maybe in SEM 1 or in SEM 2. So what is expected utility? Just give me the idea. I don't need the formula and everything. That I will discuss. But just give me the idea. What do you mean by expected utility? What do you mean by standard deviation? That you know, na? At least standard deviation you know. So what is that? Standard deviation is very much from your
Ma'am,
statistics.
the value for which is deflected from the central value of the event data set.
Okay, yes, yes. So this is standard deviation. Yes, broadly this is standard deviation, and we will discuss about expected. I think you don't know about the expected utility, but anyway, we will discuss. Do you know about the probability mass function, probability density function? These concepts are introduced already or not?
Yes, ma'am.
No, ma'am.
No, ma'am.
Hmm? Okay.
Ma'am, these are in this semester.
Oh, acha, acha, acha. So that binomial functions and all these things. Okay, fine, fine, fine. So then you don't know about that. I'm just assuming you don't know, so I will discuss it. Anyway, so what is lottery? Lottery means, say there are 100 people who are, there are so many lotteries in our real life, no? Deer lottery, আরো বলো না আরো কি সব lottery আছে? DR is very much popular because every day the results are coming out in the newspaper. Okay, there in the northeastern region, so many lotteries are happening, and these lotteries are actually legal. Government has given the permission to them to make this lottery event, because from there government is getting a certain amount of tax. So you can play lotteries. Sometimes people are thinking that lottery is very much bad thing. Obviously it is bad if you consider from the household respect, but government is considering it as a source of income. So government is giving the license to those person who are organizing those lotteries. Because a lot of lot of tickets are sold, and from there a person is coming who is getting 1 crore prize. This is the first prize, and he owned that 1 crore, but that 1 crore he cannot get to his home because of this. So 30% is taken by the government as a tax. 30 or 40%, 30%, I think it's 30%. So this is how government, this is a source of the government, and government is giving permission to make the lottery event. Anyway, so here we are not considering the lottery, this is for your PG part. Here we will discuss about the, here we will discuss the thing in terms of uncertain job. As you are the UG students, you are very much concerned about the job, so we will discuss about, we will discuss this chapter in terms of the jobs. So let me go to the first slide. We assume everything, the first, everything is certain. Yes, in case of consumer behavior, this is given, this is given, that is given, so everything is given to us, so everything was certain. But in reality, we are taking decision according to some uncertain outcomes, right? We have purchased a ticket of a train. For example, when we used to travel through, local train, we purchase the ticket, maybe the monthly ticket, assuming that each and every day the train will come in time. Okay, and we can go to our destination in time, but it may not be. So many things are happening now. The electricity problem, technical problem, agitation, so many things may happen for the next 1 month that say 30% of your attendance is deducted. So this is uncertainty, but given this uncertainty, we are purchasing the ticket. For example, use your current saving, choice of a job. Yes, look at the example, the first example, use of your current saving. You are saving your money, say now you are earning some income, and from there you are keeping money for the future consumption. So this is your saving. So you don't know how you will use your saving. Say you are saving for a purpose. Say you are thinking that after 10 years I'm going to purchase, or after 5 years I'm going to purchase Royal Enfield. But after 5 years, the situation may be like that. You have to spend your saving for some other purpose, right? So that event is also uncertain. So that uncertainty is there on your current savings. And the second one is a choice of a job. If you get a government job, then it is very good because it's a certain income in that sense. That sense, it's very good. The income is certain. And there are so many jobs in the market. Those are, target oriented, right? So in that case, what happened, a fixed money is given to you, and that money is very negligible. This is your certain income per month, and after that, if you achieve your target, then your income or your salary may be double, right? So this is uncertainty. But if you may not achieve the job, you may not achieve the target. If you cannot achieve the target, then your income or your salary will be just half. So that job has some uncertainty. The target oriented job, so many projects are there, project related things, policy, those who are selling policies, maybe car policy, those who are selling cars in the showroom, so they all have this type of target oriented salary. Okay, once you achieve the target, your income is say 50,000. But if you cannot achieve your target for the month, then your income will be say 20,000. So there is an uncertainty in this job in terms of the, not the security of the job, in terms of the income, there is an uncertainty. The next one is the concept of uncertainty. So, okay, fine. So there is a concept of uncertainty. So if there is uncertainty, that means there is risk, right? Uncertainty, actually uncertainty are sort of synonyms of risk. If there is uncertainty, that means there is a risk. So here we are dealing with this risk. Now look, okay, here we need those concepts. First of all, probability. I hope you know what is probability. Expected value, you don't know. Payoff, I think you don't know about the payoff. Payoff is very simple. Payoff means for a certain event, say this event occurs. Say you achieved your target. So this is the event which occurred. And based on that occurrence, what is your income? It's 50,000. So payoff is 50,000 for the event that you achieve your target. Okay, so this is called payoff. Payoff is the outcome actually. Outcome of the event. Okay. Now variability, you know the variability from your statistical concept, and the deviation, standard deviation, you know all these from Mishrapuri and not the Mishrapuri, sorry. This is from, what is the name of the statistic book? I just remember, I can't remember the name right now. What is the name?
Giri Banerjee Enchidash.
Okay, Enjidash. Yes. So this from these books, you know what is variability, what is deviation, what is standard deviation, but you don't know about the expected value, and you don't know about the payoff. I just given you some idea about the payoff. Actually, payoff is very much useful when we will go for the game theory, and it will be in the next sem. But anyway, payoff is something that just the outcome of the event. And expected value, I will discuss it in details. Okay, in this chapter. Now, look, I'm giving you one situation. Say there are two possibilities of a job. If you succeed to achieve the target, your income will be 400. If you fail, income becomes 200. So it's a target oriented job. The chance of success and failure is same. That is 50% chance, 50-50. We are saying that 50-50. So 50% chance is there that we can achieve the target, and there is 50% chance that we will not achieve the target. Equally possible. Then what is the expected value? Expected value, remember, there we will discuss two things which are very much close to each other. The first one is expected value. Expected value, how to get it? No, it is not done here. So what is how to get the expected value? We are writing the expected value in this way. Expected, very simple. Expected value, EV. Okay, expected value. How to get it? How to get the value of expected value? Probability into the corresponding payoff. Okay, the sum total of probability multiplied by the corresponding payoff. So here the probability is 0.5, right? Here the probability is 0 for the occurrence of the first event. The probability is 0.5 into, if you achieve the target, then what will be the outcome? Outcome is called payoff in economics. So it is 400, right? Sum total. So plus, if you cannot achieve, the chance is the chance is 50%, so it's 0.5 again, into, if you cannot achieve, then what will be your income? 200, right? So this is called expected value, and what will be its value? Can you tell me the value? 0.5 into 400 plus 0.5 into 200, what will be the value of it?
Ma'am, 300.
300. So the expected value of the job is 300. So this is how we are getting the expected value. Okay. So if you have those values, then you can just find out what will be the expected value of my job. And based on that, you have to take the decision. That is why we are discussing this. Okay. You have to take the decision that whether I will go for this job or not. Okay. So here the expected value is 300. Now I am coming to this. This is in your textbook as usual in Pindyck and Rubenfeld. Just look at this. Variability and the deviation. We are going to discuss about this. Yes. So there are two jobs which is offered to you. You have to choose one of them. First job is job 1 and the second is job 2. Okay. The first job, it's a 50-50. Both jobs are uncertain. Look, both jobs are uncertain. The level of uncertainty varies, but both are uncertain. The first job is a target-oriented, simple target-oriented jobs. It is unbiased in nature. If you achieve your target, your income will be 2,000. Okay, and the chance of achieving the target is 50%. If you cannot achieve, then your income will be 1000, and the chance of not achieving the target is also 0.5. So it's a 50-50 chance is there. So from there, if you find the expected income, you know how to get the expected income: 0.5 into 2000 plus 0.5 into 1000. If you do that, you can do that, and you must do it in your home. You can find out the expected income will be 1500. Okay, so you are getting the value of your expected income from the first job. Now look at the second job. In the second job, if you achieve the target, the chance is 99%. Look, the chance is 99% that you will achieve the target. So it's 0.99, and if you achieve it, then your income will be 1510. Okay, if you cannot achieve, whose chance is only 1% that you will not achieve the target, in that case the income will be 510. Okay, so what is the expected income? Again, it's 0.99 into 1510 plus 0.01 into 510, and it will be 1500. Now the problem is there. For both the job, expected incomes are same. Look, for both the job, expected incomes are 1500. So what will be the decision of the person? Both jobs are giving him the same expected income, then which will be chosen by the person? There is a confusion. Do you get the problem?
Yes, ma'am.
Yes,
So this
ma'am.
is the problem of the if you want to take your decision in terms of expected income, you may face this problem. Then what is the solution? The solution is here. Now look, if the expected income is not giving you the solution, then you have to go to the deviation. Okay, how the incomes are deviated? Look, here the deviation is 2000 to 1000. So the deviation, I mean, this is not any mathematical way. I'm just giving you a broad idea about the deviation. Here the range of income deviation is 1000. And here 1510 minus 510, what is the range? 1000. Here also the range of income variation is 1000. So the deviation is not helping you to find out your decision. Okay, first of all, expected income is not helping you. Then you are thinking, okay, fine, expected income is not helping you, so I'm going for the range, that from where to where my income can vary. And here also you are very much frustrated, because for both the jobs, the deviation or the range of variation of your income is same. So range is also not helping you to take the decision. Okay, so do you understand my problem? Yes.
Ma'am, can you please explain the deviation part once more?
Yes. Deviation means what will be my minimum income and what will be my maximum income. That I am trying to find out. That means what is the range of the income where my income will vary. Okay. So here also I'm watching that in that case 2000 minus 1000, so it's 1000. So the range is 1000. Okay. The gap between the lowest and the highest income is 1000. So range
Yes,
is
ma'am.
1000. And here also 1510 minus 510, so 1000. So this range is also not helping me to take the right decision. Okay, so I'm going to
Yes, ma'am.
eliminate one by one. The options I'm eliminating. The expected income is eliminated. Range is also eliminated. Then what is the another option? Go for standard deviation. Okay, so look, this is another example, actually the same example. Outcome is 2000 1500. So it's actually mathematically you can find the standard deviation. It's done step by step. But look, for the job 1 the standard deviation is 500, and for job 2 the standard deviation is 99.50. So whose standard deviation is lower?
Job 2.
Yes, so which should be chosen by the individual?
Job 2.
Job 2.
Exactly, job 2, whose standard deviation is least. Okay, because deviation means, you, if you cannot achieve, so you have to face a lot of problem. But job 2 is minimizing it. In both the cases that may happen, but in job 2 the chance is lower than job 1. So standard deviation is helping us to take the decision that okay, go for job 2. Okay, this is one thing. Now, yes, so this is the conclusion. Job 2 is better once you wants to avoid the risk. If you wants to avoid the risk, otherwise job 1 is a good one. Why? Look, because if you achieve your target na, then job 1 is giving you 2000, but job 2 is giving you 1510, right? So if you are very much confident that I will achieve, then you must go for job 1, because the highest income, the higher range is more for job 1 than job 2. Okay, so you have to take the risk. In that case, you have to take the risk. And if you are taking this risk, you are called as risk lover. Okay, you are ready to accept the risk. So you are called risk lover. You know what is your expected income, you know the range, you know the standard deviation, still you are going for job 1. Because you know, if I can achieve the target, my income will be highest. And if it varies, it varies. I may not choose job 1, you may choose job 1. It varies. In the class also, you get different people with different ideas. So if an individual is choosing job 1 with well knowing about the fact about the expected income, standard deviation, everything, then that person is called risk lover. And if you are trying to avoid it, if you are going through the standard deviation and going for job 2, then you are called risk averse individual. Okay, so risk lover is a type of individual, risk averse is another type of individual. Okay, we will discuss in terms of the choice after some time, the total utility curve, so after some time. So anyway, up to this part, is it okay?
Ma'am,
Yes.
ma'am, can you repeat the standard deviation part once more?
Yes. What is standard deviation? Standard deviation is showing how the values are deviated from the middlemost value of the series, right? Now that middlemost value can be measured in terms of mean, can be measured in terms of median. Do you agree with me? Or in terms of mode, if there is a frequency distribution. Am I right?
Yes, ma'am. Yes,
Hmm.
ma'am.
Okay, so in that case, standard deviation is showing how your income is deviated from the middlemost value. The second job is showing that deviation is least as compared to another job. Okay, so you are closer to the mean level of income in case of job 2 as compared to job 1. So more deviation means more risk, right? More deviation means more risk.
Yes, ma'am.
If you are in the mean, then you are very close to the average. If you are deviated from average, there is a possibility that you will achieve a great income, but there is another possibility that you are deviating to the lower segment so much that you will very close to the poverty level. Okay, so that risk is there. So standard deviation is giving us the deviation from the average value. So where the deviation is lower, that gives me security as compared to another. Okay, that assured me that okay, there is a high chance that your income will be very close to the average income. But where the standard deviation is very high, that shows that if you cannot achieve, if you fail, then your income will be much deviated from the average income. So you may go for starvation, you will be poor this time. In a single way, you may be poor. So the chance of be poor is higher if standard deviation is more. In our example, if
Yes,
I
ma'am.
fail, yes, if I fail, then the chance of being a poor person is very much high if standard deviation is very high. So if I want to avoid, if I want to try to avoid this risk, so I am going for job 2, because in that case there is a high chance that I will be very close to the average income. Okay.
Okay, ma'am. And ma'am, for this table, how it is being calculated?
Yes, it is calculated. Look, it is calculated like this: square deviation, then average, and then standard. This is how you can calculate. But okay, in real life, whether you can, so that is something different. Because if you want to do that, first of all, you have to know the probability. Otherwise, you cannot find your expected income. Now, whether you are getting the actual probability value, that is the question. But once you get this table, you can find these things. I just assume I have this table. I have this information.
Ma'am,
Yes.
and how we will compute the standard deviation? What is the actual formula? Because I didn't know that.
You didn't know. Standard deviation formula you don't know?
Ma'am, I didn't have statistics from 10 plus 2 level also. And
No, no, no. That was done in same one, I think.
no, ma'am, I
The
think so.
statistics was not there.
No, ma'am.
Ma'am, only game theory was there, the
Oh, that
introduction.
Venn
Yes, ma'am.
diagram and all.
Yes, on safe part.
Yes, ma'am.
Oh, standard deviation you don't know. Moreche.
No, ma'am.
So where it is? Is it in same 3?
Yes, ma'am, statico is in sem 3.
Oh, so SNMM is
Ma'am, it
discussing.
was there in GE stats.
No, this is something different, but in honors it is in same 3. Okay, so
Yes,
SNMM is dealing with that now.
yes, ma'am. But still, standard deviation is not coming.
This is actually the 3rd chapter, I think. Oh, so you need the formula.
Yes, ma'am. Otherwise, I can't understand.
Look, okay, fine. I'm just giving you, actually, I don't have the slides and everything. Actually, I'm not prepared to do that. No, I just assume you know. But as you don't know, I'm just giving you the idea. I cannot give you the formula here because it's a very complicated formula. I cannot write here with this type of pen. But I'm just giving you the idea. Say there are, say, you know what is mean? Do you know what
Yes,
is
sir.
mean? Yeah, mean is just the
Yes, ma'am.
average. Just the average. It's very simple. Now I am trying to find out standard deviation with the help of mean. I can do it with the help of median, with the help of mode, but I'm not going there. Say I'm trying to calculate it in terms of mean. Now, say there are 5 income level. There are 5 individuals with different income levels. So just forget about this example. Okay, just forget about this example. I'm just giving you the idea about the standard deviation. Now, of these 5, say the income levels are 10, 20, 30, 40, 50. Then, now, what is the mean? 10 plus 20 plus 30 plus 40 plus 50 divided by 5. Right?
Yes, ma'am.
And what will be the value? 10 plus 20 plus 30 plus 40 plus 50.
30.
30. Okay. So 30 is the mean value. Now, to calculate the standard deviation, what you have to do? You have to find out the deviation of the first income from the mean. Okay. So it will be 10 minus 30. Okay. 10 minus 30. So it will be minus 20. Plus. No, not plus. Just keep it. Minus 20. Then for the second individual, the income level was 20. So 20 minus 30, it is minus 10. For the third individual, it is 30 minus 30, so 0. For the fourth individual, it's 40 minus 30, so plus 10. For the fifth individual, it is 50 minus 30, so plus 20. So these are the deviation from mean value. Okay, now take the square of them. Why? Because that negative sign may create the problem. So just to avoid the problem from this negative sign, we are making the square. Okay, so what will be the square of the first one? The first one's deviation was 30 minus 10, so minus 20, right? So minus 20 square, so that will be 400, plus minus 10 square, that will be 100. So 400 plus 100 plus, for the third it is 0, so 0. For the 400 plus 100 plus 0 plus 100 plus 400. What will be the value? 400 plus 100 plus 0 plus 100 plus 400.
1000.
1000.
1000. 1000 square. The square root of 1000. What is the value? Square root of 1000. What will be the value? You have your phone, smartphone, so use it.
Ma'am, 10 root 10.
Okay. Divided by 5. Okay. So that will be the standard deviation. This is the way you have to find out. Actually, what you have done, you have just, first of all, you find the middlemost value, the mean value. From there, you have calculated the deviation of individuals separately. First individual, second individual, third one is on the mid value, then the fourth individual, then the fifth individual. So you just find out the deviation of them from the mean value. And then as there is some negative sign, that positive sign, so that is making some problem. So just to avoid it, make it square. Square is always positive. Okay, so just you are getting the square value of those deviations, add them. You are getting something, summation value, which is actually the square of the actual deviation. So just now you are trying to avoid that square. So for that you are taking the root. So that problem of the square is over. Then take the average of it. How many individuals are there? 5. So divide it by 5. Okay. So this is how we are doing the standard deviation. And standard deviation, as it is a square and then square root, it is unit free. Standard deviation is always positive. The income is deviated, say 50 is deviated from the mean value by 60, is like that, but it's never like minus 5, minus 6, not like that. As I have taken the square, the problem of negative sign is over. Okay. Now here, how we are doing this? Here, there are 2 income levels, right? 2 outcomes, outcome 1 and outcome 2. So just take the average of it. Now from the average value, find the deviation from outcome 1 and the deviation of outcome 2. One will be positive, another will be negative, because you can understand it's 2000 and 1000. So average will be in between this, right? So that is how some value will be negative, some value will be positive. Take the square of them. Sum them. Take the square root of the summation and then make it divided by 2. Okay, then you will get 500. And do the same thing for the second job, you will get 99.5. Okay, for that you have to find out the mean. Then find out the deviation of each and every individual from the mean. Take the square of the deviation. Take the summation of this square value. Take the root of those summation. Divide by the number of outcome. Okay.
Yes, ma'am, completely clear. Thank you, ma'am.
It may not be completely clear, but when you will get your NG dash and all, it is there. So 1 by n root over within first bracket xi minus x bar square. So it's like, it is written like this.
না ম্যাম, তাও অনেকটা হেল্প হলো ম্যাম, নাহলে এটা বুঝতেই পারছিলাম না কিছুতেই।
Anyway, when SN ma'am will discuss, she will definitely solve a lot of problem with that. So it will be crystal clear at that time. But I'm just giving you some idea about the standard deviation. So that much I need for my micro class. So this is how, so you can understand at least that it is actually the deviation, the average of the deviation of individual income from the mean value. Now that mean can be replaced by median, by mode, or whatever be the way of mean calculation, middlemost value calculation. But anyway, this is how you are getting the standard deviation. So the conclusion, I'm coming back to micro. So conclusion is job 2 is better once you wants to avoid the risk. Okay, so we are happy with job 2 now. We are risk averse individual. We are happy with job 2. Now, look at this. This is actually a sort of copy paste from Pindyck and Rubenfeld. You will get it in your book. In the horizontal axis, I am measuring income, and on the vertical axis, I am measuring the total utility. So here, remember, here as I am measuring total utility, you can understand I am following the cardinal approach. I'm going to draw the utility curve so I can measure. So it is cardinal approach. As I said, cardinal approach is very much out of the reality, but we will discuss everything with the help of the cardinal approach. We will start from there. So this is the thing. So here, a single individual. I don't know what is the nature of that individual, risk averse, risk lover, or anything else, but just an individual. So here, the total utility curve is concave to the horizontal axis. Okay. So this curve is concave to the horizontal axis. Now look, there are two options to you. Okay. Say option 1 is a certain job. Okay. And that certain job, your salary will be 15,000. Okay. Your salary will be 15,000. And given your utility curve for 15,000, your total utility is 13. Okay. So if you are going for government job, because nowadays certain job means government jobs. Anyway, so for this 15,000, the utility is 13 for that individual. There is another job offered to him. This is called job 2, and it is uncertain. Okay, here the job is uncertain. If you cannot achieve your target, then your income will be 10,000. If you achieve the target, your income will be 30,000. Okay. Now, if your income is, and the chance is 50-50. Okay, the chance is 50-50. Now, for 10,000, what is your utility? For 10,000, your utility is 10. For 30,000, your utility is 18. So you know those values. You know 10, you know 13, you know 18, you know this 10,000, you know this 15,000, you know this 30,000. Okay, so you know everything. Now, you have to choose. You have to choose one of them. Which one will you choose? This is the question. Which one you will choose? Here we need the concept of expected utility. Okay, here we need the concept of expected utility. We have discussed about expected income already. Okay, look, this is expected income. Expected utility is very similar to that. What is that? Probability into the corresponding utility. Okay, so here, not that, the payoff into the corresponding utility. So what is expected utility? Let me write here. Expected utility, very similar to expected value. But that probability which was there in case of expected value is replaced by the utility level. So utility into the income level. Okay, utility into the income level plus another outcome, that is utility into another income level. So here what we are getting, if the income level for the uncertain job, look, for the certain job there is no option, it's 15,000 and the utility is 13, we know that. But about the second one, what is the utility for 10,000? From the diagram it is 10. Okay, and the income corresponding to that is 10,000. So this is for outcome 1 for the second job. 1, 2, 3. Okay, plus utility for the second outcome is 18. So 18 and the income for the second outcome is 30,000. Right? Income is 30,000. 1, 2, 3. Tell me the value. 10 into 10,000 plus 18 into 30,000. 10 into 10,000 plus 18 into 30,000. What is the value of it?
64,000.
64.
Ma'am, 6,40,000.
Yes. So it's like that. Now, open on. Wait a minute. I have to open my book now. Just a minute. Oh, I'm very sorry. I'm very sorry. Very sorry. Here also we need the probability. I'm very sorry. Just a minute. Just a minute. Yes. So expected utility is the probability. As I said, the probability is equal. That is 50-50 chance is there. So expected utility is 0.5 into the income level, that is 10,000. Okay. 1, 2, 3, 4. Yes. Plus another outcome is also equally probable. So 0.5 into 30,000. 1, 2, 3, 4, 5. Oh, what I'm doing. What I'm doing. Very sorry. I'm very sorry. Just a minute. Give me 1 minute. Sometimes, na, our own system also cracked. So it's like that. Expected, expected utility. Okay, so I'm struggling with this pen and then I'm struggling with my memory also. Expected utility is equal to the probability, that is 0.5 into the utility. Yes, now hopefully I'm right. Utility of 10,000. Okay, utility of 10,000 plus 0.5 into utility of 30,000. Now tell me the value.
14.
It will be like 0.5 into utility of 10,000 is 10 into 10 plus 0.5 into utility of 30,000 is 18. Okay, so if you make it, that is 10 into 0.5 plus 18 into 0.5, it will be 14. So this is the formula. I'm very sorry that I have given you so many times the wrong information. So try to remember, this is how you have to find out the expected utility, the probability into the utility of the event or utility of the payoff. Okay, plus probability into utility of the another payoff. Then just put those values and you will get 14. Now I have to compare. Is it okay now? Expected utility?
Yes, ma'am.
Expected utility is the probability of the outcome into the utility of the payoff of the outcome. Okay, and the sum total of all those. Here there are two outcomes. So the utility of the second outcome into the utility of the payoff of the outcome. This is called payoff. So here the value becomes 14. Now I have to compare this expected utility with the second job. The second job, for the second job, my utility, as that job is very much certain, the utility is also certain. Okay, so there is no expected utility. For job 1, the utility is 13. For job 2, the expected utility is 14. So which one should be preferred? For job 1, the utility is 13. For job 2, expected utility of job 2 is 14. So which one
Ma'am,
should be?
job 2.
Yes, job 2. So here, look, here the individual is choosing the risky job. Job 2 is risky. Job 1 is certain. Job 2 is uncertain. But still, as the expected utility is more than the actual utility of job 1, so the individual is going for job 2. So this is the usefulness of expected utility. This is why we are using expected utility. Okay. Okay. Look, I have done this, but still I was struggling. Oh, it is there neatly. Yes. So look, আমার হাতের লেখা যদি কারোর বুঝতে এখানে অসুবিধা হয়, hopefully সবারই হয়েছে, তো it is written here neatly. Expected utility is the probability of the first outcome into the utility of the payoff of the first outcome plus utility of the second outcome into the utility of the payoff of the second outcome. So if you put those values, you will get 14. As 14 is greater than 13, so job 2 is preferred if the person wants to increase his expected utility. Definitely, where the utility is more, he will go for it. So he will choose job 2. Okay, so this is how he is choosing his job. Up to this slide, is it okay?
Ma'am,
Hmm?
ma'am, how can we find the income corresponding to the expected utility?
No, I'm not getting income with expected utility. I'm getting the income and the corresponding utility. That information is given to me. This is my income, 10,000. And if 10,000 is my income, my utility is 10 because I know the slope of my total utility curve. or the shape. Everything about the total utility curve is known to me. So that is how we are getting the utility. In reality, look, in reality it is not possible, because total utility is not the reality. That cardinal utility is not the realistic one. But if you assume cardinal utility is true, then you can get the value. For a certain income, you are not getting expected utility. For a certain income, you are getting the utility. But when there are so many income levels for different outcomes, then you have to find out the expected utility, which is nothing but the average, or rather weighted average. It is weighted average. The weights are the probabilities. বলো।
ম্যাম যেমন গ্রাফে যখন এক্সপেক্টেড ইউটিলিটি যখন মানে 14 আসছে, তখন ইনকাম হরাইজন্টাল অ্যাক্সিস আই গেস 16 আছে, তো ম্যাম
হ্যাঁ,
ওটা
না
মানে
না, ওটা অন্য জিনিস, ওটা অন্য জিনিস। দেখো, যখন তোমার এক্সপেক্টেড ইউটিলিটি ফর জব 2 ইজ 14, then you are, look, at first you have to compare expected utility with the utility of job 1, and you have chosen your decision. Okay, you have taken your decision that job 2 is okay. Now this is just a cross check. If your utility will be 14, if utility is 14, then your income should be 16,000. Okay, for 16,000 salary, your utility is 14. And the average of 10 and 30 is 15. Then for
ইয়েস
job
ম্যাম।
2, 10 and 30, these are the range, 10,000 or 30,000. So the average of 10,000 and 30,000 is 15. And if it is 15, then your utility is 13. So in terms of income also, you are going for job 2. You, first of all, for 13 and 14, 14 is greater than 13, so you are going for job 2. Done. But to get 14 level of utility, your certain income should be 16,000. Okay, but the job 1 is giving you 15,000. In that respect also, you will prefer job 2.
ওকে ম্যাম।
Job 1 is giving you 15,000 certain, and expected utility for the uncertain job is 14. But to get 14 level of utility, your certain income should be 16,000. But as job 1 is giving you only 15,000, so you are leaving it, because you need 16,000 at least to have the same level of utility. So this is just a cross check type of thing.
Ma'am,
Hmm?
ma'am, if the individual is risk averse, ma'am, then he will choose the job 1, no job 2. Ma'am,
No,
job 1.
he will not choose job 1 in any way. Because look, for job 2 also, there is a high chance that income is 30,000. There is a chance that you will achieve 30,000. For job 1, you cannot go there. It's 15,000 fixed.
Okay. So, ma'am, it is both applicable for job risk averse and risk lover person.
No. I'm not telling you this person is risk lover or risk averse. This comparison, this is not the time to compare it. But for that individual, if this is the situation, he will go for job 2. That much I can say.
Okay, ma'am.
Okay, and look, that 15,000 is taken intentionally because the average of 30,000 and 10,000 is 15. So this is just the average income of the second job. If you forget about utility, if you forget about expected value, everything. So 15,000 is just average of the second job. So that is why I have chosen job 1 as 15,000 salary. So we are leaving the average income for this uncertain job. We are going for uncertain job because the expected utility from job 2 is more. So we are going for the risky job. And this is the conclusion. Because here the individual wants to increase the expected utility. Okay.
Okay, ma'am.
Now I am going to the next.
Ma'am,
Yes.
can you please present the graph, slide of graph once more?
Yes.
Yes, ma'am, I didn't get the average part because the average of 10 and 30 is 20, ma'am. 10 plus 30 divided.
Oh, yes, 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 yes.
Yes, ma'am.
So that part is wrong. Yes. That explanation is wrong. Yes, yes. So just forget about that. Huh? This is not 15 is not the average of it should be 20 in that case. If 30 is
Yes, ma'am.
20, then the average is 15, right? So average is 20, right, right. So that is not the way. But here we are getting the thing that if 15, we are leaving that 15,000 job, 15,000 certain job for the uncertain job because the certain job's utility is lesser than the expected utility of the uncertain job. And to have this utility that is 14, we need a certain job with salary of 16,000. If 16,000 salary is offered to us, if job 2, look, if job 1 is offering 16,000, in spite of 15,000, if job 1 will offer us 16,000 and then utility will be 14, that will create some confusion. Okay, then it is not easy for the person to take the decision because from job 1 the utility is 14, from job 2 expected utility is 14, then the confusion may arise. But given the situation, there is no confusion because the expected utility of this uncertain job 2 is higher than the utility of the job 1. So as the person is interested to increase expected utility, so he is going for job 2. Okay.
Okay, ma'am.
So the next one. Type of risk preference. There are basically three types of individual in the society. The first one is risk averse, as I said. The second one is risk lover, and the third one is risk neutral. Now, who is risk averse? Who prefers certain income than risky income with same expected value, as I said here. Sometimes it is not working. Give me 1 minute. Here, as I said in this example, that if job 1 is offering 16,000 with utility 14 and job 2 has same expected utility, so that may create the confusion, right? That I said at the end of this discussion, that if job 1 will offer 16,000 in spite of 15,000, where the utility is 14, and from job 2 the expected utility is 14, that create the confusion for the individual. Now the individual is confused. Expected utility is equal to the utility of job 1. Then which one should be chosen? Right? Do you get my problem?
Yes, ma'am.
So here, if that individual, here comes the risk averse. Here, if the individual is risk averse, if the individual is risk averse, and now so the situation is like that, it is 16 and it is 14. Okay. So here the individual is confused which one to choose because utility is same for both. If the individual is risk averse, he will prefer job 1. Why? Because job 2 is risky job. There is a chance that your income may be 10,000. So he's just trying to avoid that risk. The risk is very important for him. He is risk averse. He is trying to avoid the risk. So in that case, he will go for job 1. On the contrary, if that individual is risk lover, he will go for job 2. Why? Because there is a chance that he can earn 30,000. He is so interested about this 30,000, he is preferring job 2. With well knowing the fact that there is a chance of earning 10,000, but still he is going for this job 2 as there is a chance of earning 30,000. So same expected utility. Expected utility is 14 for both the cases. But risk lover will go for job 1. Risk averse will go for risk lover will go for job 2. Risk averse will go for job 1. And risk neutral will choose any of them. He is neutral. He is indifferent. Job 1 is okay. Job 2 is also okay. Anything will work. So do you get the point?
Yes, ma'am, get it.
This is how you can differentiate individual. If with the same level of utility, if the individual is choosing the certain job, then he is risk averse. With the same level of utility, if the individual is choosing uncertain job, then he is risk lover. And if the individual is indifferent between these two, he is called risk neutral. And it is written here. Indifferent between the risky income and the certain income with same expected value. Okay. So any query from this slide? No query, na? So this is an example of risk cover, and let me finish it. I think this is just a minute. Oh Baba, I may not finish it today. I wanted to finish. So risk averse. Who is risk averse? Risk averse means, as I have shown you, look here your problem is coming. I think Shruti was talking, na, the average is 20,000. So that
Yes, ma'am.
so 20,000 is here. Look, the same thing I have chosen. In spite of 15,000, here the certain income is of 20,000. Okay, so job 1 is offering you 20,000, and the utility corresponding to that 20,000 is 16. Okay, now if for the certain job the values are same, the certain job's expected utility is 14. Remember, we have calculated it. For this uncertain job, the 10,000, 30,000 job, your expected utility is 14. And for the same level of average income, you are getting 16 utility. So as 16 is greater than 14, you are going for the certain job. And why 16 is greater than 14? Because you are risk averse. Your total utility curve is like this. Okay, your total utility curve is concave. Now look at the risk lover. Yes, here it is written. Is 10,000, 30,000, so it's 14. We have derived it. The utility of the income of 20,000 is 16. As 16 is greater than 14, the person will choose the certain income, that is the income with the job with 20,000 salary. Okay. Now for the risk lover, the uncertain job is fixed. The income levels are fixed, 10,000, 30,000. But here, the certain job also 20,000. For certain job, your utility. Now look, for the risk lover, the total utility curve is convex to the horizontal axis. Okay. Now for 20,000, the utility level is 8. Okay. And for the uncertain job, the expected utility is 10.5. Just find out the value, 0.5 utility of 10,000, 0.5 into utility of 30,000. So utility of 10,000 is 3, utility of 30,000 is 8. So put those values, you will get 10.5. Okay. So as 10.5 is greater than the certain income's utility, that is 8, so the person will prefer the uncertain job. Right? So why it is like this? Why the value of the second job expected utility has changed? Because the curvature of the graph is changed. Okay, so for the risk lover, he is going for the uncertain job, and for the risk neutral, he is neutral. It is straight line through origin. So the certain the job and the utility of the certain job, the utility is 12, and the expected utility, if you calculate for the second job, it will be 12. So as 12 is the same, so he is indifferent between the certain and uncertain jobs. Okay. Up to this point, is it okay? Make yourself clear. I don't go for, I'm not interested to go for the risk premium and all other things. I will solve it in the next class and then I will start the production. No issue. But make yourself clear first.
Ma'am,
Yes?
ma'am, these graph of risk covers I didn't understand.
This one.
Yes, ma'am.
Look, here job 1 is certain. The salary is 20,000. And so your utility is 16. Job 2 is uncertain. Salary may be 10,000. Then your utility is 10. Salary may be 30,000. The utility is 18. And the probability is 50-50. Okay? So in that case, what will be the expected utility of the uncertain job, that is job 2, is done here. Probability is 50, so half into utility of 10,000 plus half into utility of 30,000. Now utility of 10,000 is 10, so put that value. Utility of 30,000 is 18, so put that value here and you will get 14. Okay, so 14 is the expected utility of the second job, and the utility of the job 1 in our case is 16. So as 16 is greater than 14, so individual will go for the certain income. Now tell me your problem.
Yes, ma'am. Now it is clear.
And the same thing I am doing again here. But as the curvature has changed, so that is why the values are changed, the utility levels are changed. But I just fix those income levels as before, that 10, 20, 30. These are same as before. But the utility corresponding to 10 is different, 20 is different, 30 is different now. 30 is same actually, but 10 and 20, these are different. Why? Because the curvature, initially it was concave to the horizontal axis, now it is convex to the horizontal axis. Okay.
Ma'am, here also the 20,000 is corresponds to the job 1 certain job.
Yes.
Okay, ma'am.
And the 10, 30 for uncertain job. So look, expected utility of the job 2 actually, 0.5 into utility of 10,000, 0.5 into utility of 30,000. Those values are changed now because of the shape of the curve. So it is now 3 and 18. If you calculate, it will be 10.5. And certain job, it's 20,000 and the utility is 8. So as 8 is less than 10.5, so individual will go for the uncertain job.
Ma'am, these graphs will vary from person to person depending on.
Exactly.
Okay.
Risk averse may not be risk lover. Sometimes it may happen, it depends on the income level, but in general, a person maybe, you can see in your friend level also, no? There's some person who are, we are calling them daredevil. You know? Class disturb করে, ম্যাম বকলেও শোনে না. So they are risk lover. They are ready to accept zero attendance. They are ready to accept 4 marks. Everything they are ready to accept. So they are actually risk lover. But there are some individuals, I should not go for gender sensitive comment, but generally girls are like that. Generally, remember, generally they are very much interested to follow the norms, the rules of the class. Generally, this is the experience from my student life and also from my son's student life that I can tell you that generally the girls are more eager to maintain the law and order as compared to the boys. So in that case, they are they are trying to avoid the risk. So they are risk averse. But obviously the difference are there, exceptions are there, but generally. It's a general comment. Don't take it as a gender sensitive one or like that. I'm not at all like this. And this is the risk neutral. Okay, for risk neutral, it's like it's a straight line from the origin, and the expected utility of the uncertain job is equal to the utility of the certain income. Hmm. So that is why he is indifferent. Look, it depends absolutely on the shape of this curve. Okay, and this shape is showing the preference about the risk of the individual, and it varies. Okay, I'm not going there. That I will discuss in the next class. It will be heavy.
Ma'am,
Hmm.
I have a doubt in the table for standard deviation.
Standard deviation. Okay, where it is? This one. Okay.
Ma'am, for job 2, ma'am,
Hmm.
the standard deviation means how it is coming 99.50.
So, what is the value for you?
Ma'am, if I find the average of the two outcomes, then means 1510 plus 510 divided by 2, it is coming 1010.
Hmm.
And if we find the difference from both the outcomes, then it is coming 500. And
Yeah, have you
if we,
taken the square one?
yes, ma'am, if we take it square, then it is similar to the first job.
Standard deviation is same.
মানে আমার ক্যালকুলেশন হিসেবে তো এটা আসছে, আমি শিওর নই।
তাই আর কেউ করো তো। Uh, just a minute. Because that I have taken from Pindak and Rubenfeld. And as it is written in this book, I have just copied it. I didn't do that, but I have just copied it from your textbook.
মানে আমি এটা শিওর নই, মানে ঠিক বলতে গেলে।
No, the formula, you are following the formula, na? Then
ইয়েস
square,
ম্যাম,
then summation, then root of it, and then average of it.
ইয়েস ম্যাম।
So it's written as 99.5 here. Hmm. Then I have to calculate. Can you do anyone else? Can you do it just for a cross check? It is actually table 5.3 in my book. I've just copied it from there. Please do it in your home, and if you have any doubt, please ask me. And I'm just giving you the reference in my book. It is chapter 5 and table number 5.3. Do in your home. Once you know the formulas are very easily available in net as well. You know, the mm, Google Google is always there to helping us.